Welcome to finintro. Today in this lesson we're going to talk about compounding. And in compounding we're basically going to do the same thing we've already done. So we're going to start with a very simple future value problem. Future value is equal to, I don't know, present value is going to be $1,000 negative because we're going to invest it. We're going to claim an interest of 5%. And we're going to make a total number of compounding periods 10 years. And so the first assumption that we're making here is that we are doing this for 10 years and the compounding happens once per year. So if I have a 10-year period, 10 years, 0, I'm compounding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So the actual moment where I calculate interest goes 1, calculate interest, 2, calculate interest, 3, calculate interest. But that's not how the real world works, right? Often in the first year alone, we may compound monthly or we might compound quarterly. Let's do quarterly and see what happens. So let's do quarter 1, quarter 2, quarter 3. So this is quarter 1, this is quarter 2, and this is quarter 3, and then finally we're going to have quarter 4. And in each one of these quarters, we're going to compound each time. So the way we've been calculating before, the way we should have started to calculate this is to calculate this one time, all the way here, one compounding. What we're going to do is we're going to switch this, and we're going to calculate compounding here at first quarter, and we're going to calculate compounding here at this quarter, and we're going to calculate here at this quarter, and then finally we're going to calculate here. That is 1, 2, 3, 4 different times that we're compounding. And this should make sense, because if you're doing a mortgage or something, you're going to compound it monthly, or you're going to compound bonds. We're going to compound annually. So let's really quickly solve this problem. Let's solve this problem doing it annually. The first thing I'm going to notice is that I have one payment per year. If you click orange, clear all, you'll get a little sign that shows you payments per year. And I'm going to type in $1,000, and these are negative. And I'm going to put that into my present value. That's this one. And then I'm going to do 5% into my interest rate. And then I'm going to do 10 years. So here's my 10 years. I'm going to do 10 years and put it into my N. And I'm going to get a solution of future value 1628.89. So 16, whoops, let's go back to green. 1628.80 and 89 cents. All right. And now we're going to figure out how to compound quarterly. So we're going to do the exact same thing. You know what? Let me erase all of this. And then I'm going to create this line here. And what we're going to do is call this annual compounding. And then we're going to do this in quarterly compounding. So that I can take advantage of the fact that I'm going to do it 4 times per year, I've got to make a modification. I've got to take, let's just look at 1 year like we did before. 0 to 1. And it's going to be quarter 1, quarter 2, quarter 3, and quarter 4. 1, 2, 3, 4. Over the entire period, if I'm looking at the entire period, down here, let me scroll that up a little bit. If I'm looking at the entire period, I'm looking at 1 year here. So I'm going to put 1 year. But I'm not doing it over 1 year. I'm not compounding over 1 year anymore. I'm compounding 4 different times. 1, 2, 3, 4 different times. And so what I want to do is I want to multiply my 1 year times the 4 times that I'm compounding, my 4 quarters, and I get 4 equals to my new N. So I'm going to multiply this guy by 4. But in this case, I'm not doing 1 year, right? I'm doing 10 years. So that's going to be 10 years times 4 is going to give me 40 N, or 40 quarters. And that's my total number of N. If I do that, I've got to also make an adjustment for my 5. So let me come over here and erase all of this. I'll go again. My 5% is over the course of the entire year. But if I do 5% of the entire year, because this is an annual rate, I've got to go back and make a modification so that I can appropriately take the interest rate into account for each quarter. So instead of multiplying by 4 like we did with my total numbers, n equals 4 for n, what I'm going to do is I'm going to divide by 4. And I get some number. 5 divided by 4 is equal to 1.25. 1.25%. And this is going to be per each quarter, right? So 5% for the year divided by 4 quarters gives me 1% for quarter. So this is going to be 1.25, 1.25, 1.25, 1.25 for each quarter. So I'm going to go over here to interest rate. I'm going to put divide by 4, and that gives me 1.25%. So I'm going to go back up to my present value. Let me erase this a little better. So I'm going to go back up here to my present value. My present value stays the same. That doesn't change. I'm still only depositing the $100 into the investment. But now, instead of calculating for 5%, I'm going to calculate per quarter at 1.25. And instead of calculating for 10 years, I'm going to calculate for 10 years times 4 quarters per year for 40 quarters. So I go to my calculator, and I note that in my calculator I have all this other stuff. Let's start from scratch. Let me clear everything out. No memories. I'm going to start with $1,000 and put it into my present value. Note that it's negative because I'm the one making the investment. Okay, it's coming out of my pocket. And I'm going to switch this to 1.25 and put that into my interest rate. And I'm going to make 40 quarters, my total number of n, and calculate future value. Future value here is 1643.61. So 1643.61. Well, what's the first thing that we can notice here? The first thing we notice is that this number is smaller than this number because I did this quarterly. Why is that? Well, the case is that the reason that is because I'm taking the principal here. Let me go with my $1,000. I'm taking my $1,000 and I'm calculating it one time at 125. It's going to grow just a little bit. And then I'm going to calculate it again at 125. It's going to grow just a little bit more. And it's going to go over here and it's going to grow just a little bit more. And I'm going to run it again. It's going to grow just a little bit more. Instead of calculating it just once over the entire thing and having it grow just a little bit less. So here what we're doing is we're increasing the rate at which that money is going to grow by increasing the compounding. Okay, we can compound in any size that we want. We can compound annually, which is where we started our class. We can compound semi-annually, which is very popular for bonds. Quarterly for corporate and stuff. Monthly for mortgages. You can compound daily. We can compound a variety of different ways. And we can break it up as often as possible. So we can do it by okay, so let me stop for a second and go back and say annually, obviously, it's going to be 1 time. Semi-annually, it's going to be twice per year. Quarterly is 4 times per year. Monthly is 12. Daily is 365. And in my class, it'll be always 365 unless otherwise indicated. Okay? So what do you think is the smallest amount that we could... what do you think is the smallest amount that we could compound? By the hour? By the minute? By the second? Microseconds? Nanoseconds? Well, we can compound continuously. Continuous compounding. And continuous compounding basically means we're compounding at an infinite number of breaks. Okay, so we can compound continuously an infinite number of breaks. And here we can't plug it into our calculators, so we're going to have to use a different equation. And that equation looks something like this. Future value is equal to our present value, e to the x. But we actually put something instead of x, so we're going to erase this x here. And instead of doing the x or some number, what we're going to do is we're going to multiply n, the total number of periods per year, times R, or I, which is the rate for the entire year. Now this may seem a little complex, but it isn't really. I'm going to walk through it with you. And what I want you to do here is do this in reverse order. You're going to do this one first, then you're going to take this one to the e to the x, and then finally you're going to multiply. So let's go back to our problem. Okay, future value is equal to, I don't know, present value is equal to 1,000. N was equal to 10 years, and I, or R, is equal to 5%. Okay, so what we're going to do here is first multiply, no, step one, multiply these two guys. So that's going to be 10 years times, and remember this is decimals again because we're doing traditional math, 0.05, and that's going to give me, let's see, 10 times, you know what, let's clear the calculator so there's not any confusion. 10 years times 0.05, and that's going to give me 0.5. Okay, so I'm going to take that 0.5 and I'm going to go on to step 2. Step 2, 5 or 0.5, but I don't want 0.5. I want e to the 0.5. Right? So I'm going to hit 0.5, and notice that in my calculator, 0.5 is already there. You know, you might as well just leave it there. And we're going to find e to the x. Where is e to the x? Where is e? Here's e to the x. If I hit red shift, you'll see e to the x. And all I'm going to do is just click e to the x. And you'll notice that your number went from 0.5 to 1.6487. Okay? In this scenario, you hit the number first, and then you hit e to the x. So as a matter of fact, let me go over here, erase this, and I'm going to call this e to the x to signify that all you're going to do is push the button e to the x. This gives you some number, 1.6487, 1.6487, and so on. Step 3, finally, we have our 1.6487. All I'm going to do here is multiply this by my present value, which is 1,000. So times 1, 2, 3, 4, 1,000 equals, scroll down a little bit. So this equals to $1,648.72. This is our total calculation of our future value if we compound continuously. So again, when we do our calculations, I'm going to scroll back up here. We calculate compounding depending on the number of breaks in the year, or we do continuous compounding, which is all the time, and we use this equation to do that. And if you look back up at the top, we didn't do anything that was really fancy other than our regular future value problems or present value problems, except we made a modification to the interest rate. And if we modify the interest rate, we also have to make a modification to the number of periods. Good luck.